think we are on 9. No. Oops. Let me put the mic a little bit closer. Okay. So before we start, I think we should create our arrays first, and I think a 30 variables is okay. So let's create this 200. I think that's fine too. Then so we want 30 variables. Then let's make 3 different strings. So pi for Python, and this will start with this. Then G for, let's say G will be for Go, but let me just, we should go. Do we need to do right make or something? Okay, this will of course cry. Okay. Why don't we have our work scripts running? Don't we have? Do I really need that? Let's see. Nope, it's still not finding the main function. Do I retry it myself? Let's see. Okay, no errors at least. Can we just define it like this? Or I don't remember Go that much. Do we need to write make and then do like int? Then it needs size. How to just create this variable like something like this? Will this work? Oops, not size, int. Yeah, this seems fine. And let's just try to print it just to be sure. So let's input this. Oops. Yeah. Okay, so C and Go will be the same. So Go, we don't need Go. We just need the C option with this. Okay, then should I do this with a for loop, or can I just use sec? So 1 to 30, 31 maybe. Then let's do, so pi plus equals rand, but it's a variable now, so let's just find a function, and this will echo that one. Let's see. Yeah, this is okay, but during echo we don't want new lines, so just that. Let's see. R&D. Yeah, this is okay now. So now this, and what was our variables names? I forgot those. Okay, so one was pi, and pi plus equals. Then let's try first. So dollar. What was the function name? R&D, I think. Let's see. Yeah, but it just run one time. Oh, because we have a variable called R&D. Then what should we do? Then if we do something like this, so R&D equals should we do that? We can define this one more time and we can just do something like that. So rnd equals this. I think this will be okay. Let's see. Then let's try this for one more time, and now we will call rnd function and do this. Yeah, are those still the same? Because of the variable names. Let's just create a different variable. So rnd let's just forget all of those. And so pi equals this, c equals this, and while in our for loop we can just do something like this. So a equals to what? Dollar. What did we do? Did we echo? Do we need echo? No, just this. So dollar parentheses random and that. And after this, so what should we do? Pi plus equals dollar $a and a comma, I think, and the space would be good. And c plus equals dollar $a and a comma. Let's see. Yeah, this seems fine to me now. And pi plus equals a closing bracket, and c plus equals a closing bracket as well. So let's just echo these variables now, pi and c. Yeah, okay. I think, yeah, this could just stay here because we will write several different sorting algorithms, so I will just put this in here just to stay. Okay. So before we start, I will show you the algorithm that we are gonna do, because I think that would make much more sense. So, and I can remember it as well. I didn't practice these for some amount of time. So we'll start with bubble sort, the simplest one, and let's go with sort now. So it goes to a for loop until here, then swaps the big variable with the previous one, I think, and it just does this couple of times, probably n squared times, because it goes 9, 8, blah blah, so double for loops. And if the element is greater, then it swaps it with the other one. Okay, so bubble sort is the first algorithm that we will start doing. So let's start with Python first. So let's go with sort.py, and let's take our variable and let's go with array equals this. So before we start, actually let's put this on main, and let's start writing our function. So bubble sort, this will just take an array, and so double for loop, so we will have two for loops, and the first variable will be in range 0, then length of array minus 1, because since it looks to the next variable, then we will not go until the length of the full array. And now with j, so for j in range, so j will be in a range with 0, and after this the length of array, but I wrote this wrong, like this, so length of array minus 1 minus I, because for example, if you think, for example, our array size was I think 9 before, so 9 minus 1 is 8, so until 8, and minus I is 0, so it's 8. when I is 1, so 7, it will go with decrement. Right. And this should be it, I think. And this will also going to be an incrementing one, not a decrementing array loop. So after this we need to swap two variables. In Python you can swap them pretty easily, swap two variables. So array j comma array j plus 1 will be equal to some condition. So what will be that condition? And we can do it like this. So if we don't need parentheses in C. So if j plus 1 is smaller than array j, or you can do this different. You can do it like this. So if array j is greater than array j plus 1, then array j and array j plus 1 need to swap, need to switch places. So array j plus 1 and array j, and I think this is it. Let's try it. So let's go bubble sort and let's give our array to it, and let's print it afterwards. Let's print the first array too. What to give? Yeah, like this. Okay, I think this looks fine to me, but just to be sure we can just double check. So we can do something like this. We can just comment this line and just use the sort of Python, and afterwards we can compare. We can switch these, and we can put this print to here and put this to here. Sort. Sorted? Yeah, that's okay too. Let's see. So I think they are the do they have differences? So 0, 11, 14. Okay, this is a little bit hard to see, so let's make this smaller and let's do this. Yeah, I think they are the same. Yes, so this is for our first sorting algorithm, but why do we have 3 prints? I don't understand that. I commented the lines. Oh, because of this, my bad. Yeah, this is better, and yeah, they are the same. So this is for Python, pretty easy and simple, like 3 or 4 lines, and let's go with Go. I hate Go needs folders to work. So main. And email, let's create our array first. So this would be equal to an array of integers with holding these. Okay, now let's import fmt2. And let's print our array first, like previous one. So fmt.token, and let's print array. And let's implement our bubble sort now. So func bubble sort. And what will this take? It will take a slice of integers called, we can just call it array. Oops. Was it like this? Yeah. So we will just have 2 for loops again, like before. So we can just define it like this in Go. For I in range, should we do it like this? I am not sure. Oh, let's just do it the same as before, and this equals to smaller than to len of array -1 and I++, and for j 0 again, and now j is smaller than smaller than what? Length array minus 1 as same, and minus I now, and j++. And now we can just use the same checking condition again. So if our array's jth element is greater than array j+1, now what we need to do, we need to swap those. And I think Go has the same syntax too, so you can just swap two variables like Python. So array j, array j+1. Now this will be equal to array j+1, array j. And let's run our function and let's check. By the way, if you are seeing this, I am not returning anything because arrays are dynamic variables, and if you are using dynamic variables, then you won't need to return anything. Dynamic variables are always changed and their references are sent always. And actually that is why, if you don't know C, you should try to take a look at C. So let's go with C now. So vim sort.c. stdio main. So C will be a little bit different. A little bit, not much. Let's create our array now. So like this again. And for starters, there is no printing array in C, so we need to write that. So let's start by that as first, and we need to write a simple macro, and it is this for me. Yeah, it just takes all of the elements and divides the size of the first element so that you could know its size. So let's start by defining a function like this. So this will take an integer array and it will take a size of it. So size int n, and a simple for loop again. So for I equals 0, I smaller than or equal to n, and let's just do something like this. So an integer space comma, then what ith element of the array, and after this we can print a new line because there will be no new line, so we can just use this, just a simple new line. Okay, so now we need to implement bubble sort, but before we implement bubble sort, we need to swap two variables in bubble sort, obviously, and there is no defined function to do this in C, so we need to write a simple swap function. So swap function will go like this. So void swap, and this will take two integer pointers, a and integer pointer b, and now we need to swap those. To swap those, we can just do something like this. So this XOR equals to this XOR equals to this, and this XOR equals to this again. This will swap two variables, and after doing this, now we can start writing our bubble sort function. So void bubble sort. This will take two variables again, an integer array and the size of that integer array, and it will just have two for loops as before. So for I equals 0, I smaller than n minus 1, then let's go with j. So for j equals 0, j smaller than n minus 1 minus I, and what will we do? So we will print, not print, we will swap the two variables if the other one is greater. So there's a small typo here, I think, n minus 1 minus I. So if array j is smaller than, not smaller than, is greater than array j plus 1, now what we need to do, we need to swap the variables. So swap, we are going to swap array plus j, and we are going to swap array plus j plus 1. This is, if you want, you can do it like this, but if you want, you can give the reference of the integer array variables. That's totally your choice, it doesn't matter. Then let's call our print array function. So print array, not this. So print array first, and what will we give? Our array and length of that array. Then we will call our bubble sort function, and we will give array and length of that array one more time. Then let's print the array one more time to see the differences. Let's run this. I think this looks the same as before. for to me. Yeah, I think this is it as well. So we've written in 3 different languages, and I think we can compare them now. So C is the oldest language, and I can open these 3 for you with Vim or with terminals. Yeah, let's go with Vim. So this will be this. Let's do this. So A. Okay, cool. So left one is Python. Left one is Go, right one is Python, and let's open C too. Can't we open this horizontal? Okay, let's go with split. Okay, so let's take a look at the differences. So C is the oldest language, and it's a little bit longer than the other ones. And Python and Go are pretty similar, so they just have a simple function that just takes one argument, and they have the same if conditions, just swaps the variable as the other one. It's just totally the same. So these languages actually pretty much look like the same, just for this case, but they are really different languages. And as for C, the leftmost one, so this is a little bit different than the other ones, because in C you need to calculate or think much more than these 2 other languages. So you need to create a swap function, unlike these 2, because in C you can't swap the variables easily like just doing this. So you need to swap the variables by using a simple algorithm. Actually, if you want, you can create a temporary variable too, and you need to implement your own array printing function, because you can only print primitive types in C, no dynamic types, or no arrays. And aside from that, they are pretty much the same. And in C also there is one more difference as well. So you need to send 2 variables instead of 1, because if you just send this integer array to this function, that will not work, because in C it has no knowledge of the size of the array. If you send it to a function, it's just a pointer, not like these. These 2 are more complicated classes or structs beneath them. They are not primitive variables. In C, arrays are, you can think of primitive as well. They are not created of structs or something. They are just simple, definite sized arrays, and only the function defined in it knows the size of it. That's why we calculate this length at integer main. When you go out of these brackets, there's no knowledge of the size of them. And since this is an integer array, not like a string, the computer or the compiler doesn't know where to stop, so you need to handle those issues as well. So I think we are done with bubble, and I think we can go with insertion sort now. So let's go with insertion now. So insertion, actually, you can think insertion sort like this. Insertion sort is actually you can think of it like the backwards definition of using bubble sort. And instead of going from left to right, now you go from right to left. That's you can think of the only difference in insertion sort. But you start from the leftmost right, so you will start from 1, and you will go until the end of it. Then you will swap the minimum variables. Actually, that is the goal of it. That is what we will do in this case. Okay, so let's start with Python again. So let's go with sort.py main, and let's take our variable now, this, and array is equals to this, and now def insertion sort, and it will just take an array. So let's create our first for loop now. But before creating that, actually we don't need that in Python. We can just create the first for loop. So first for loop will start I from 1, and it will go until the length of this array, and it will have a step of 1. That's the first thing. And now you need to define the keys and the starting position. So starting position will be the one less of your current position, and key will be your current array argument. So key will be equal to array I, and j, which will be the key, is going to be the 1 minus of I. And now instead of using a for loop, you can just use a while loop now. So you can go with while, and in while there is two things we need to check. So since we are going leftwards, you need to check if the condition is greater than 0 or not. So while j is greater than 0, that's our first condition. And now we need to check if the key is greater than our current element. So if array j is greater than our key, so this means that our key was the one next of it. Now we can set the variables now. By set I mean doing this. So key now will be equals to array j, and now we are going to decrement j by -1. So now you can think of it like this. For example, if our array j, so the element before our current element, is greater than the key, then we assign the current element, so it's actually array I, to the previous element. By doing this, we are preserving this key in somewhere else, and when this is done, now we can put the original element to where it needs to go. So it is here. So array j plus 1 will be equals to key. And let's print out array again, and let's call our function again, then let's print out array again. Let's see. Yeah, I think this is good to go, and I think we can go with go now. So let's go and let's call this insertion and sort dot go. So package main, what else do we need? So we need to import fmt, then func main. In main we are going to have a array, a slice actually, in go, and this. Yeah, I think we are good to go now. So let's print it first. So println a. We've called it a, it doesn't matter. And now we need to have a function, and it will be called insertion sort, and it will just have a single variable, and it will be array, and it will be a slice of integer. And same as before, so we are going to have a for loop that starts from the first element. So for j equals to 1, j is smaller than length of array, length of array, this would be I actually. And what else? And I plus plus. And now we need to set those two variables. So key will be equals to array I, and j will be equal to I minus 1. So this is our first step. Now what we need to do, we need to handle that while loop, but we don't have while in Go, so we need to write it with using a for loop. So what will be our conditions? So for I think nothing, and in here what was our condition? So while j is greater than 0 and our key is greater than array j. And what will be our second condition? The last condition is going to be j minus minus, but we can define that later. So while doing this, we are going to set array j plus 1 is was it like this? Yes, array j, I think. And we will going to decrement j by 1, and after doing this, array j plus 1 will be going to, actually this is wrong, I think, no, it's correct. And now array j plus 1 will be equals to key. Then let's call insertion sort and give a to it. Then let's print our array one more time. Okay, we did a small mistake. While this is going to be smaller than, yes. And I think go is done too. So we will now go with C. Okay, and I will shock you with C. I will write a weird thing with C for insertion sort. So vim sort.c. Let's include stdio. And what do we need? We need length. And what else do we need? We will need. Actually, this is not needed, but I wanna show you a different way of doing this. So I will just copy paste that one function that we've written before. I will just take this. So we have our swap function, and now we can start. Let's go with, let's write our name first. Okay, it's already here. So integer array is equals to this, and we also need this as well. So to print array, so let me print paste this too, and let's print our array first. So r and length r. Okay, and now let's start writing our insertion sort. So void insertion sort. Two variables again, so integer array and the size of it. And now for our I equals 1, I smaller than n, and I plus plus. And actually I even don't want to use brackets, so what else? So for our j is equal to ith element, and while j is greater than 0, and while array j is smaller than array j minus 1 and j minus minus. If this satisfies, then we can just do something like this. So swap array j, comma swap array j minus 1. R plus j minus 1. Yes. This is actually a weird insertion sort, but in C you can do this. This is, I think, pretty cool. And if, let's try to check it first. So let's call our insertion sort, and what length of our array, and let's print the array now. By the way, I'm kind of started to get bored of doing this, so I could switch to GTK application after some amount of time, but it works smoothly. So in C you can implement insertion sort with just using 3 lines. This is pretty cool. So let's just give a small break. By the way, guys, I handled the issue with Pico. It's enormously smooth now. It has 0 issues, and it's working really nice, and it's really fast. I think maybe even faster than the DCC Silax fork. This is really nice. So let's give a 5-minute break. back, guys. So I think I will skip two of the algorithms and just implement merge sort, because I want you guys to see the differences of merge sort between the three languages. It is a little bit different than the other ones, so let's go with merge. And what should we start with now? Python, or we also always started with Python, so I think we can start with CS first. So I think I will just copy one of the files, C files from these. So let's just copy sort.c to here. And now let's delete this too. And I think we won't need swap, but yeah, it can stay, it won't hurt. So in merge sort there will be two functions, so let's start with watching the video first. And let's take a look at here as well. So it splits the array in half, then it compares the two arrays. So we will have to create two more arrays to be able to do this, and compare the values between them, then put them into the original array. That is going to be our first step to do this. And so as we talk, we will need two functions to do this, and the first function that we need to do is actually checking this. So by checking this, I mean we need to do a simple recursion to split the array in half, then so 0 to half and half to end, and until the left part is smaller than or equal to right part, we will continue. If it's not, we are going to disable the function. We are going to end the function. So it will go like this. So void merge sort, and now this merge sort will have three variables instead of two. This is going to be the first variable. So int l means the leftmost part of the array, and int r means the rightmost part of the array, not the end of it. So it will be the length of the array minus 1. And the condition that will satisfy when we know it is done is this condition. So if our left part is greater than or equal to our right part, then we need to return, because the function is ended now. And now we need to calculate the middle part. So int m, we can just calculate the middle by doing something like this. You can just divide it if you want to. So l plus r minus l divided by 2. If you want, you can do this different too, but this is what I like to do. Some people prefer r plus l divided by 2, but I think this is okay as well. So after this, now we need to call the function, the merge sort function again, because first we want to split the array, not sort it. So we will call itself again. So it will use recursion, and it will be like this. So L to M, so left to middle. Now merge sort one more time. So now middle plus 1, because we've included the middle in the left part, and to what? To R now. And after this, we will call another function called merge, and this merge will have three variables, actually four variables. So it will have our array, it will have left, middle, and right. And now let's implement the merge function. So void merge. This will have four variables, L, middle, and right. And just to start, as I've said, we need to define the sizes of the two arrays that we are going to split and the other parts of it. So let's go with it first. So n1 will be the size of the first array, so we can just go with it like this: m minus l plus 1. So why m minus l plus 1? Since we've included this to l to m, its size is going to be 1 less than this, because 1 greater than this, because it's included actually 1 more time than this. You can think of it like it. And n2, the other array, now this will just going to be the size, this will have the size of r minus m. And now we need to create two arrays, so l will have the size of n1 and r which will have the size of n2. So these are done now. Now we need to copy the variables to these left and right arrays. So we are going to have two for loops: int I equals 0, I smaller than what, and 1, and I plus plus. And now what? Array, not array, li is going to be equal to array l plus I. This is it. And now what? Now the other one. So for int I, we can just use I one more time. And now size of what? n2. And now ri is going to be equal to l plus m plus 1. You can just copy these actually. So l is the starting point, m, is this correct? Yes. So middle part, the leftmost part, and 1 greater than it. Or you can just do it like this actually if you want. M plus 1 plus I. Yes, I think this is it. So middle part, should just copy this and just put the increment variable after it. Now what? Now we need to define two variables that will hold as the counters of these two. So we can just call them I and j. And these both will start from 0. And now we need to define another variable, and this will hold the place of where we are just currently at in the original array. So you can just call it k. These variable names are just a preference, so call whatever them you want. And what is our starting point? It's L, so it is going to be L. Now we need to define a while loop, and our condition is going to be while I is less than size of n1, so the size of our left array, and while j is less than size of n2, the rightmost array. So while doing this, we will compare the two arrays, and we are going to put k on those. So our statement is going to be like this. So if our li is less than or equal to our rj, so if this is the case, then what do we need to do? We need to do this. Array k will be equal to l I plus plus. So let's think why it's like this. So if our left array's ith element is smaller than our right array's j element, current array's kth element, which we hold as the key, is going to be equal to our left array's ith element. So why the plus plus? These plus plus states that we incremented I by 1 because we copied that variable to our original array. And what is our second condition? Actually, if you want, you can just use an else here, it doesn't matter. So our else is going to be pretty much the same. Now it is going to be array rj plus plus. But we are not done. We need to increment k by 1 because we filled the kth element of the array. So this condition, let's assume that this condition is done in our program. What else we need to check? So this statement states that if either def of 1 is filled, any one of them is filled, then this statement will collapse. So we could either not fill I, the leftmost array, or the rightmost array. So this, you can think of this like we need to fill the array fully, because this might be done, but we are not sure that both of the arrays are completely done. So we need to write two more while loops, and these while loops are actually going to be pretty simple. So while I is smaller than m1, and what will be our statement in it? So we are just going to do something like this. Array k plus plus is equals to l I plus plus. This is it. And while j is smaller than n2, like the previous one, array k++ is going to be equals to rj++. So after doing this, we filled our array and we can try our function now. So let's call merge sort. So array 0 is our starting position. What's the rightmost part? So length of array minus 1. And let's try to run this. Is it correct? I think it's correct. We can just do a simple compare by doing something like this. So actually we had the variables in somewhere around here. Okay, it doesn't matter. So in bubble, I think in Python we had this sorted array. Let's just run this, and in here let's just run a.out. Let's see, so 0, 11, 14, 15, 25, 26, blah blah until 99. Yes, I think this is done now. So in C, you will do it like this. It's pretty long, so it's like 60, 70 lines. We don't need this, by the way. But more lines doesn't mean that it's slower than the other algorithms. This is actually faster than the two we've written. So this, I think, have the, actually let's just make a comment in here. So this is, I think, n log n. And these two, the other algorithms are, this is O of n squared. Actually, let's show it like this. And also, the bubble sort is also O of n squared. They have minimum and maximum types as well. The average of those are order of n squared, but in merge, it's always big O of n times log n. It's always, and it's faster than the other two algorithms that we've written. I think I will skip writing it with Python or hello-ness, but I want to show you how to write this with Go, because in Go you can do this a little bit differently. So let's go with Go. So Go mod init, and let's call this merge and sort.go main. So fmt and func main. So we are going to have a array now, and copy this, paste this, and yes, in Go you can write all of this in a single function, not two function, and I think it's pretty cool. So with Go you can do something like this. So let's start by writing func merge sort. So which variables will this have? It will have 3 variables as we've spoken before. So it will have an array, a slice of int, and an int l comma right int. Can we define it like this in Go? Yes, we can. So 3 variables as before. So we need to do the recursion thing as before. So what was our recursion thing? So if L is greater than or equal to R, we are going to return. And if not, we are going to have a new variable which will be m, and m will be equal to L plus R minus L divided by 2. So this will be the middle. Then what do we need to do? We need to call merge sort twice with using recursion, and we will give R. Yes, but I am trying to build the new release, but it's pretty hard. So it's still using the older release. It has less features than now, but you can update it when you install it actually. So merge sort L comma m, and merge sort array m plus 1 comma r, and after this we call the function merge. But with Go there's no need. You can define an inline function. So you can do something like this: merge field df func. And you can also do this as well. So it has the knowledge of these two variables. Yes, we have. Let me just share the link. Give me a second. Oh, not this. So I will take this m and put it to here, and this merge function will do not have any variables. So in the merge function, what was the steps that we first took? So we will have thanks bro, appreciated, two variables. So m1 is going to be equal to m minus l, and m2 is going to be equals to m minus l plus 1, and m2 is going to be r minus m. This is going to be the size of it. And now we need to create two variables, and I want you to see the differences between C and D. Go. So this step all of the same, but we are not writing a merge function in a different way. We are just defining it as a variable in Go, and this is a really cool option with Go. You can just define function variables. This is I think the best thing that you can do with Go, and you also omit the variables in it. You can just use them because it's inside the function. Okay, let's continue. So after this we will have two arrays now. So, and can we use slices to copy? I will just use for loops because I don't remember those too much. So a variable which we can call it L. L is going to be equal to an array of integers. Actually, we can use make a slice of integers, and it will have this size of n1. Actually, instead of giving execution times, there was a site called what was the name of it? Race or something like that. Good afternoon, bro. Something like this benchmark, I think. Maybe this. Yes, this is it. So let's try to take a look at Go. Can we compare Go with something? So let's compare Go with C. I have some amount of time. It's 11. So C versus Go runtime differences. So 1.20 seconds, 0.28. No, this is Go. All Go. Where's C? Cool. Will you use Linux to play games? Where's the differences? Oh, okay, this. These look pretty much the same, but I can see some C. Let me see. Yeah, try it. Believe me, you won't believe it how games perform in Linux. So in this, C is like 2 times faster than Go, with greater inputs. In other input 5000. Let's take a look at this. So it's reading nearly 3 times fast than Go with C, and it's 1.5 times faster than Go in this embody algorithm. But I think it should be much faster. Yeah, for example, this one. Oops. So in using nucleotide, something called nucleotide, it's like 10 times faster than Go, and it uses half of memory than Go. This is just because of the garbage collector. But in some algorithms they are close. Or for example, these are just written in Go. For example, in this hello world, we don't even want to compare this. FASTA, what's this? Only Go. Yeah, I think no language will ever be faster than C, the newer languages, and they will never be close to C as well. But each language has their way of usage, so you obviously don't want to use C in sure. For example, you obviously don't want to use C in some network programming because it's really hell. Or for example, I don't know if you know this, but everyone is using machine learning with Python, and so people think it's written in Python, but all of the machine learning libraries are written in either C or C++. So why are people using it? Because you don't want to, because they are enormously complex to write. For example, if you want to write OpenGL, you need to use 4-dimensional matrices or 3-dimensional matrices, and with C it's really hard. But when it comes to speed or when it comes to optimization, they always use C in the background or C++. For example, no good game is written with another language aside from C++ if it has good graphics, and it won't ever be, because Go, I think Go will surpass Python because it's better in networking than Python as well, and it has some odd things. It's like, I don't know, I don't like that error checking in Go. You need to check everything, but it prohibits you to make more mistakes, and I think that's a good feature. But Python has its use cases as well, so if you wanna calculate huge numbers, you just need to use Python. In doing that with other languages, it's really hard. Python automatically calculates everything. I like Python, but the thing I don't like with Python is whenever I write a Python code, whenever I write a Python program, I can never be sure if that code is good or not, if that code is optimized or not, because Python most of the time works. It doesn't give that much errors, and that can be both good or bad, but I don't know. But I'm really sure that only Python programmers, for example, people just use Python for their life and they didn't even attempt to learn other languages. I'm really sure that they don't know they don't even know programming. They just know Python, and I think it's really different. Tutorials on Go. I just tried to solve some algorithms and then just check the Go website, but I don't think there is that good Go sources in the internet, and there are some weird things that you can do with Go, and you just need to learn them yourself. It's a weird language. I just don't like the strict syntax of it, but you can do most of things easily with it. Thanks, bro. For example, just people who just code Python even don't know the difference of this. Let's assume you have a variable, okay? So let's call this a15, and let's print this a. And let's assume that you have a function called change, and this has a variable called a. So if I ask them this, so let's add 5 to a, and let's print this a one more time, and after doing this, let's send this a to that change function. And I've witnessed this with like 3 to 4 years expert Python programmers, and for example some really good machine learning programmers, and they answered this wrong. And at that time I really understood that if you just learn Python, you don't know programming at all. For example, if I run this function, I've asked them what will be the output. So most of them actually said correctly. So since this doesn't return anything, they said that it will print 15, then in this function it will print 20, then it will print 15 again. And that's correct. And I said, okay, that's right. How about this a was not an integer, but it was an integer in some array. So now I will change this as a0. When I asked them the output of this, they all said the same thing again. So it will print 15, 20 and 15 again, but it's wrong. It will print 20 because you are sending an array to a function, and since they are using Python, they don't know the differences between sending an array or sending a class to a function. But when you learn some low-level language that doesn't have that library optimization, that memory optimization, and when you have to deal with these by yourself, you understand the differences between these. By the way, this applies for any other language aside from C and C++. Maybe I don't know Rust, so I won't make a comment of it. So L and R is done. Now I think we can copy slices in Go, but I don't remember how to do it, so I will just check it from internet. Just this. Not that. Copy test to source. Not that. Copy. Yeah, okay, let's try to use copy. So copy, then what's our destination? L, and what's our source? So our source will be a slice of our array, but the variables will change. So it will, can we do it like this? Go until M. I don't know, maybe. We will see, and in this will go from, what was it? Oh, I forgot. So M plus I, so this will go from M plus 1 until the end of it. I don't know if this will work or not, but we can just try it. So let's try it like this. Let's print array, for example 0 to 5, and it wants us to call merge, so I will just call merge here to omit the errors. Yeah, I think this works. How about 5 to continue? Oh, I think this works as well. Okay, so we can just simply copy the slices like this with Go. This is a really nice feature. And now what else we need to do? So we need to create two variables. So var I comma j, and this will have the type of integers, and Actually we are going to have k as well, but we can just assign k to L as a start point. So now we have I and j2, so let's assign I and j2 as well. So I 0 and j 0. I think, yeah, I don't remember, so I will skip. So we've assigned I and j, but I think Ghost assigns them automatically, but doesn't matter. So now we are going to have a while loop, but since there's no while loop in Go, we need to do a for loop. So for nothing, and while, we can think this as while I is smaller than n1 and j is smaller than n2. While we're doing this, yes, I agree. Yeah, each language has a use case. Aside from, I hate some languages like PHP or Java. I really don't know how people like those languages. That's odd. So if our L I is smaller than or equal to our R of j, if this is the case, now what do we need to do? So our array's kth element is going to be Li and k++. So else k, actually we can put this k++ to here and put I++ to here. I don't think we can do this in Go. Yes, we can't. So we need to put it on a separate line. So rk is now going to be equals to rj now and j++ here. So this is actually our for loop done. Now we need to do our for loop again. So while I smaller than m1 and open bracket, so I will just copy here and paste this. So rk is going to be equal to li, and now we need to put k++ too. What do we have? An error, so this should be plus. So let's just copy this and let's just paste this, and this will be now j and this will be n2, and now this will be rj instead of li, and after this we can just call merge. And now let's call our merge function and let's see if it's working or not. So merge sort our array 0 as the left variable and len r minus 1 as the rightmost variable. Then let's print our array. Oops, we had something going wrong here. Let's see. ij, li, rj. I think this is okay. Maybe here. I am not sure, but maybe the issue is because of here. So until m is equals to l plus r minus l divided by 2. This is correct as well. We had a lot of zeros, so let's just do something like this. I will just print L and R here to see the arrays. Yeah, they are, these are, I think this seems wrong. Copying slices. Let's try it with a for loop so that we can understand. So for I is equal to 0, I smaller than m1 and I++, li is going to be equal to array l plus I, and for I equals to 0 again, I smaller than n2 and I++, and now ri is going to be equal to r n plus 1 plus I, right? Let's see. Yes, so obviously we can't copy the variables using the slices using like that. I don't know why it should work, but it probably doesn't create copy of those variables. I think that's why. I am not sure, but this is it for Go. So with Go, you can write them in a simple one function, just using a single function and using a variable function. And I think Go is a little bit simpler than the other ones instead of these weird for loops, because it doesn't have a while loop, and you don't need to send the variables in this, even that. And I think that's it. So I will end sorting algorithms now, and I will actually try to take a look at this issue, guys, in Pickcom. In here. Yes, this one. And I will just check if someone commented on this. Not this. Not that. Yeah, that one. Someone commented? No. I will just have a small break, guys, then try to handle this issue. Let's go to Pickcom now. And the issue is related in here. I was trying to solve it before. I'm back. Mechanical engineering. Uh, do, do you know programming? I don't know what mechanical engineers do actually. So okay guys, so first I will try to show you the issue that the guy reported. So the issue is something like this. Let me make pickcom first, and let's close it. So he is using a custom shader, and in that custom shader it has a feature like this. Actually I will copy this as well and put that in here. Okay, why do we have, oh, because of the path. Okay, so I will just copy this and put that in here and comment this, I think. Let's see. Okay, let's see. Yeah, so if you can see, the border changes in the focused window after some amount of time, and he is saying that when an animation kicks in, as you can see now, that border resets to the original state instead of staying in the current position, in the current state. And I am trying to solve that issue, and I think, and I'm pretty sure it's caused in somewhere around here, in actually here. So if old win image, this sets some properties and it sets border width and corner radius to 0. I don't know what happens when you comment this, but I just want to try it, and let's see what will happen when we comment it. Okay, why do we have an issue? Let's run this. Let's move build and let's run make again. I think this will handle that error. Yeah. Okay, let's see what happens when we remove that. Nothing happened actually, but that issue continues. It did not disappear. So when the animation kicks in, the custom shader goes away. Let's try to solve that. By the way, I think this removing that actually handles the corner issue as well. So by corner issue, I meant this. Maybe you can't see it from the live video, but before deleting that, the corners have become sharp before the animation, because all of those things were set to 0 before. So I will probably just remove these and try to do something like this. So I will paste this to here. Did I copy that correct? Yeah, okay. And in this function, instead of using WinImage, I will try to use old WinImage, and let's see what will happen when we do this. Let's make again. Let's build and let's open a And now let's try to reanimate. No, it still goes back to the original state. So custom shader added, win image, and let's see what's happening in the animation process. So if it's not animating, it's working correctly, so it comes into here. Okay, and it uses the variables of reg paint inbound and reg visible. And this one uses reg bound, reg visible, reg paint, and reg paint inbound. I will try this before doing something else. I will try to move this when the shader changes. Yes, that resets it as well. So there's definitely something going wrong around here. So in here, reg bound, reg visible, reg paint inbound. These ones actually seem same to me. Let's go to process window for painting. Something could maybe is happening in here. So opacity. Do we have the shader here? Process window for painting. Yeah, it has the window image. So it sets opacity, applies alpha. It doesn't do anything related to borders, I think, in here. Yes. So there is something maybe going wrong with it. Okay. So border is set in here, and if it has the old window image, we are setting the old window image, but maybe it's not applied properly. Okay, so let's see what else. Process window for painting gets called, but whenever an animation kicks in, everything gets reset. Maybe in above, I'm not sure. Let's try to search for anim here. Okay. So if it's not animating, we know that it's working correctly. Reg bound, reg visible, reg paint inbound. Okay, where do we set those variables? Let's try to check. In here. I'm not sure now. Maybe we need to corner radius. This is the border width. just want to try to put this in here for now. And let's see if something will change. Okay, no, it still gets reset when the animation starts. Okay, then maybe not, the issue is not in here. Let's take a look at the animation now. Okay, and shaders, custom shaders. Okay. Bye bro, take care. Okay, I'm not sure if it's called in here or not. Let's try to take a look at window.c. If that's the case, then custom shader. Okay. Okay, this is the one that's setting the shaders. And this releases the image. Grab. Maybe somewhere around here. So this grabs the old Win image, but it uses the bounding shape of it. What other options did this have? It just has the bounding shape. Yes, it doesn't take it with the shaders. That is probably the issue. Okay. Then we don't know where it takes that image, because I think when we put it to here, it copies that after it's released. So this probably doesn't make any sense. It just sets the image property for the current shader, not the previous one. And it doesn't seem to be working correctly for the other one. I wonder if we try to do something like this. So if we copy this and go to here, and when it's grabbing it, can we do something like this? I just want to try this. I really don't think this would work, but I just want to try it. No. It somehow skips the custom shader, and maybe it's happening because of the time of it. So what was the shader configurations? Change after some time. corrupts the image. Let's search for shader here. Okay. This gets cold. That's okay. But the shader is gone. In animations. And it's handled in here. When this is this works. But this won't work. And this only does for resizing as well, so it also doesn't work in this as well, in this statement. But it's just actually handling transparency. I'm gonna go to win image. I am not sure, but I just wanna try this anyways. This would probably break lots of things, but I'm just curious. Do we need to compose for it to work? This would probably break something. Didn't. Okay. No, it's still not working correctly. Okay. Let's try to put this in here. Then we try it one more time. So color change? No, it's still not working. Then where does this happen? I have no idea. Break paint in bound. Yes, same variables. If it's not animating, it gets cold in here. That's odd. Let's try something like this then. So after this if condition, let's try to put this in there. So after the animation is handled. Oh, yes, we are making a step now. It's having a little bit of issues. But at least it's working a bit. This handles it okay. But where to put it to work correctly? rendering it during each animation will is what probably makes it laggy. So if it's animating and it's having the old image, if we put it in else, let's see what will happen. We are having a little bit of glitches. Did its color change now? Yeah, it changed. Okay. Now this resets it too. Because if we are resizing, the other one gets cold. So to handle that, we need to put this in somewhere else. Okay, I think we can try to do something like this. So if is animating, yes, like this, and if we put this after this part now, oops, what did I copy? Yeah, if I copy this part to here now, this is in this if, right? Where does this skip gets called? Okay, I will just put the skip in here. Oops. Then if this is the case, and let's see. Oops. Okay, we are having an issue somewhere around here. Okay. This seems fine as well. In 588 in the end. Oh. Missing braces. Where did we did that mistake? No, I just copied this to here. Let's see if this have issues. Yes. Let's see what this is for now. So this is just going to use this option now, and we wanna, what do we wanna do? We wanna put this in a condition if it's animating, and delete this, then copy this to here, then close the brackets. Okay, why are we having this issue now? Oh, all of these are, yeah, I think this is okay now. So in skip, like this. And now this option does not need ease animating now. Let's see. Small, we have small glitches. Did it change the color now? Yes. But it resets the transparency. Now we need to fix it as well, but I think this is okay. This could be handled. At least that custom shader works now. What if we put this to here? If we put that to here, then the other two pops out. Only animate opacity here. Okay, this is it. I will take a look at this later, guys. I need to go to home and sleep. So I am closing the live for today now. So see you later, guys. Take care. Bye bye.